When the French Air Force released its new, clearly defined aircraft development programs, it sparked a wave of entirely new projects. These new aircraft shared almost nothing in common, aside from being twin-engine designs. But the French manufacturer Breguet decided to go its own way. Even though the military officially preferred twin-engine aircraft, Breguet's engineers seriously considered a classic single-engine layout right from the start. That is how their single-engine project came to life, designated the BR-1001. At the same time, its twin-engine sibling was being developed under the designation BR-1100. Right up until the end of 1953, this single-engine project was seen as just a backup plan. To keep costs down and speed up development as much as possible, engineers tried to maximize parts commonality with the twin-engine BR-1100. Right at this turning point, NATO emerged as a massive potential customer. In late 1953, NATO leadership drafted a sweeping new program. By the spring of the following year, they officially announced its launch. This was the Lightweight Tactical Strike Fighter program. The primary mission for this new jet would be providing close air support for Alliance ground forces. They planned to select the winner through a fierce competition. After that, an initial pre-production batch of about 30 aircraft would be built. This would be followed by full-rate production. Projected demand was huge. Total requirements were estimated at anywhere from 600 to 1,000 aircraft. This would be enough to equip up to 50 combat squadrons. Under the terms of the program, production of the winning aircraft was going to be a joint effort. It would involve the aerospace industries of several NATO countries. The finished fighters would then be distributed proportionally, in proportion to the size of each nation's armed forces. All production contracts were to be signed by the defense ministries of the participating countries. Funding for this massive project would be shared by the participating nations themselves. It would also be supported by a special international initiative called the Mutual Weapons Development Program. The requirements laid out for this future standardized fighter were incredibly strict, but pragmatic. It had to be as light as possible, structurally rugged, and incredibly simple to maintain. Designers were required to incorporate a bare minimum of avionics. They also had to rely on the simplest possible tooling for field repairs. Key technical requirements for the competition included the following. First, the aircraft's empty equipped weight was strictly capped at 5,000 pounds. At the same time, its weight with a standard combat load could not exceed 8,050 pounds. Also, its maximum takeoff weight was capped at 10,000 pounds. Second, the fighter had to operate from rough dirt strips or hastily prepared field airstrips laid with pierced steel planking. This was reminiscent of World War II. The length of these runways would be limited to just 2,950 feet. Moreover, for a fully loaded aircraft, the total takeoff distance to clear a 50-foot obstacle could not exceed 3,445 feet. Third, the fighter had to deliver impressive speed at low altitudes. It had to reach at least Mach 0.95 right at sea level under standard atmospheric conditions. During these high-speed regimes, the aircraft was expected to maintain flawless handling and crisp maneuverability. Its roll rate at high speeds and low altitudes had to be at least 100 degrees per second. As for internal armament, the basic arsenal was supposed to consist of 4 50 caliber machine guns with 300 rounds per gun. On top of that, the fighter had to carry at least 2 500-pound bombs under the wings, or 4 unguided 5-inch rockets. The Bristol Orpheus turbojet was chosen as the power plant for this future standard NATO aircraft. At the time, this engine was already powering the British fallen Nat light fighter. The developers had access to the BOR-3 version of the engine. It produced about 4,850 pounds of maximum thrust. But the engineers knew full well that this just was not enough power for modern mission requirements. Bristol offered a heavily upgraded BOR-12 variant. This version delivered over 8,150 pounds of thrust on afterburner. Despite the tempting offer, Breguet's management played it safe. For the initial prototypes and test aircraft, they decided to stick with the proven BOR-3 engine. Meanwhile, they waited for Bristol to come up with a more optimized version. Out of a massive number of proposals submitted to NATO, officials selected just the 3 most promising aircraft. These were the Italian Fiat G.91 fighter, along with 2 French aircraft. These included the Dassault Étendard 6 and the Breguet 1001. The French Air Ministry issued the official order for the first prototypes to Breguet in late December 1954. At the same time, officials wanted to speed up flight testing for these new fighters as much as possible. Because of this, an additional order was placed alongside the French and Italian prototypes. This order was for 27 pre-production Fiat G.91s. Like most aircraft from the company, the BR-1001 light fighter was developed under the watchful eye of chief designer Georges Ricard. Before cutting metal for the first prototype, the engineers ran extensive wind tunnel tests. These tests were run simultaneously for two different models. These were the BR-1001 and the BR-1100. The designers also leaned heavily on the invaluable experience they had gained while developing their previous project. This was the BR-1002 Interceptor. Interestingly, during the initial tests in the fall of 1953, the development team took a mock-up of the BR-1002. They simply clipped its wings to simulate the proportions of the upcoming BR-1001. Later on, of course, the team built 6 highly accurate mock-ups of both light fighters. This included a rather large model built to a 1 to 3.5 scale. Evidently, the Air Ministry at the time viewed the BR-1100 program as the real priority. The lion's share of funding and resources was poured into that project and its dedicated naval variant. As a result, work on the BR-1001 slowed down significantly. This caused serious delays in building the first prototype. This aircraft was supposed to become the standard fighter for the NATO alliance. While this shift in priorities ultimately caused a lot of headaches and had its fair share of downsides, there was a silver lining. For example, in early 1956, 5 different mock-ups were tested in a wind tunnel at the Cornell Aeronautical Laboratory in Buffalo, New York. The results from those tests forced the engineers to make some critical design changes. They stretched the nose of the fuselage and recontoured the aft section of the cockpit. Most importantly, they applied American engineer Richard Whitcomb's area rule to the airframe. By that point, construction on the parallel BR-1100 project was already too far along. This made it practically impossible to incorporate these revolutionary aerodynamic updates. But for the BR-1001, the engineers were able to completely redesign the fuselage. This gave the aircraft a massive aerodynamic advantage. It was not until November 1956 that the factory finally started cutting metal to build the first Breguet 1001 prototype. Comparative testing of the competing aircraft was slated to kick off in September of the following year. This meant that by the time the trials began, its main rival, the Italian Fiat G.91, would already have been flying for several months. This would give it a serious head start. Interestingly, even before it rolled off the assembly line, the new aircraft was given the name Taon. In French, this word translates to horsefly. It is also a clever anagram for NATO. It was a fitting nickname for a fighter with such an aggressive, combat-ready character. It was the middle of summer, just 7 weeks before the critical competitive trials were set to begin. On July 25, 1957, the first prototype of the Taon light fighter finally took to the skies. At the controls was experienced test pilot Bernard Witt. He successfully completed the historic first flight from the French Melun-Villaroche airfield. With very little time left, the technicians and test pilot from Breguet worked around the clock to refine the new aircraft. In that short period, they managed to introduce a series of major design improvements. They dialed in the roll rate. They ironed out an unwanted yawing tendency and increased the effectiveness of the spoilers. On top of that, the engineers managed to eliminate dangerous vibrations. These vibrations developed near the air intakes at high speeds. They also fixed a pitching moment that occurred whenever the speed brakes were deployed. Simple adjustments alone were not enough to fix those last 2 problems. They had to heavily modify the airframe. They completely reshaped the intakes and relocated the speed brakes. Initially, the speed brakes on the sides of the fuselage were replaced. A single large brake panel was installed under the tail section. Later on, they decided to move it further forward. They mounted it underneath the fuselage, just ahead of the main landing gear struts. Along with this, the rear ventral fin was replaced by an aerodynamic strake under the nose of the aircraft. All of this extensive modification work was successfully wrapped up by August 1957. By September, the all-important competitive trials had kicked off. Unfortunately, the Taon light fighter still had a few noticeable teething problems. For example, there was an aerodynamic asymmetry. Because of this, pilots constantly had to trim the aircraft in flight and counteract a persistent yaw. The engineers still could not figure out the root cause of this at the time. This massive NATO-sponsored competition took place from September 16th to October 5th, 1957. It was held at the French Flight Test Center in Bretigny. Over that time, the Taon managed to fly 31 test sorties. Beyond the handling issues we already mentioned, the light fighter took some flack for having a takeoff distance that was simply too long. Its numbers noticeably exceeded the strict limits set by the competition. Notably, a total of 5 aircraft took part in the trials. There were 3 official competitors and 2 French jets flying as unofficial entries. Out of that entire group of 5, only the aircraft from the Italian company Fiat managed to meet those strict takeoff requirements. It had to clear a 50-foot obstacle within a total takeoff distance of 3,000 feet. At the same time, it was a bit unfair to fault the Taon for occasional tail strikes. More precisely, it was scraping its protective tail skid on the runway. This was because the jet had excellent low-speed handling. This allowed it to safely lift off at a very high angle of attack. That steep pitch is exactly what occasionally caused the skid to tap the concrete. Despite the initial criticism, the flight reports from the American, British, and French test pilots were overwhelmingly positive. They unanimously praised the exceptional handling of the aircraft across its entire speed envelope. The jet demonstrated outstanding flight characteristics and incredible maneuverability during every phase of flight. As a combat platform, the fighter proved to be a highly capable option. It flew perfectly whether it was clean or loaded down with external ordnance. The ground crews who maintained the jets during the competition were just as impressed with how easy the aircraft was to wrench on. The Breguet company put a massive emphasis on sortie generation rate. This means the ability of the aircraft to fly back-to-back missions without long delays on the tarmac. Engineers smartly distributed the systems and components. These needed attention or refueling between sorties. They were spread across 8 different zones on the fuselage. This allowed an entire team of maintainers to swarm the jet simultaneously. They could do this without getting in the way of one another. To make things even easier, designers included plenty of access panels and maintenance hatches. The results of this approach spoke for themselves. During testing, the turnaround time of the aircraft between sorties was evaluated. This included a full system check, refueling, and rearming. The time was cut down to a staggering 6 minutes and 40 seconds. None of the other competitors in the contest could even come close to that record. Component swap times were equally impressive. It took maintainers a mere 14 minutes to replace an aileron. A main landing gear tire was swapped out in 3 minutes. The canopy could be changed in an unbelievable 1 minute and 38 seconds. Even the heaviest maintenance turnaround took just 47 minutes. This included a full engine swap, topping off the fuel tanks and fully rearming the jet. The clock ran from the moment the tires hit the runway to the moment the jet went wheels up for its next sortie. Early on, engineers figured out 2 main issues. These were the flight instability of the aircraft and its excessively long takeoff roll. They believed they could iron these out pretty quickly. Sure enough, directional instability was the first problem they resolved. To fix it, designers reworked the aft fuselage. They installed a custom fairing over the exhaust nozzle and added a flight stabilization system. One of the most demanding phases of the competition required flying a typical combat profile. This was done along a strict route with a specific weapon loadout. Interestingly enough, the French Breguet 1001 was the only aircraft capable of successfully completing this mission. Thanks to its stellar performance, the Taon instantly shot to the front of the pack. It quickly became not just a favorite among the French, but also earned high praise from British aviation experts. However, on January 8, 1958, things took an unexpected turn. The Special Committee evaluated the official results and passed its recommendations up the NATO chain of command. NATO leadership then announced its final decision. The Italian Fiat G.91 was declared the winner. Naturally, this sent shockwaves through the program. The decision was flat-out rejected by both the French government and the developers at Breguet. The reality is, this choice was largely dictated by factors that had absolutely nothing to do with the technical specs of the aircraft. High-level politics took center stage. Because of this, the French concluded that the entire competition had been rigged from the start, with a predetermined outcome. Their suspicions turned into absolute certainty when they learned that even before the official results were announced, the Americans had already ordered a small batch of the Italian fighters. This was done to evaluate their combat capabilities. The backlash was so severe that some French representatives protested. They flat out refused to sign the final document, openly calling it a scandal. For its part, NATO leadership tried to smooth things over. They wanted to soften the blow of the defeat. They justified the decision by stating that the Fiat was considered just a basic first-generation aircraft. Meanwhile, the Breguet design was slated to become a more advanced second-generation fighter. This would happen should a military need for it arise. For a while, there was still some hope in France that the military would order both aircraft simultaneously. In the summer of 1958, for example, rumors were flying around about plans to buy 200 G.91s and as many as 360 BR-1001s. But a compromise like that went completely against the whole point of the NATO program. The program was built around creating a single, standardized aircraft for every country in the alliance. Because of that, all this talk never translated into any official decisions. Meanwhile, back in the spring of 1958, French aviation authorities had already officially approved the new BR-1003 project. They formally awarded Breguet the massive contract to develop this highly anticipated second-generation aircraft. NATO published its own corresponding development program in June of that year. But by then, the French Air Force had completely lost interest in light aircraft of this class. Their own development program had fizzled out, and seeing the Italian Fiat win the competition only left them bitterly disappointed. The French High Command never seriously entertained the idea of adopting an Italian aircraft anyway. It came down to a mix of bruised national pride and the simple fact that they just did not have the budget to procure that kind of hardware. Despite all the political drama, development pushed forward. In mid-January 1958, the second BR-1001 prototype took to the skies for the first time. This airframe featured a whole host of major upgrades. It incorporated every single technical improvement tested on the first aircraft. The second prototype's main job was weapons system integration. Unlike its experimental predecessor, it was built as a fully functional combat aircraft. Their flight performance was virtually identical. In theory, the second version was expected to be slightly slower at low altitudes, but faster when flying above 25,000 feet. In practice, though, that assumption was quickly shot down. After some further testing, they fitted the first prototype with new aerodynamic fairings that seriously boosted its top speed. Thanks to these upgrades, the first prototype was chosen for a pretty ambitious mission. It would set a new world speed record on a 1,000-kilometer closed circuit. The legendary pilot Bernard Witt was tapped to take the controls for this historic flight. Before the record attempt, the aircraft was specially prepped to strip out as much weight as possible. They pulled out the heavy built-in armament, replaced it with extra fuel, and carefully faired over all the gun ports in the fuselage. On top of that, fairings at the wing roots made the airplane's aerodynamics even cleaner. Combined, these changes led to an incredible result. The aircraft's top speed at high altitude jumped from Mach 0.98 right up to the speed of sound, hitting exactly Mach 1. On April 25, 1958, the first Breguet 1001 prototype flew a test circuit in France and smashed the previous speed record. It clocked an average speed of almost 650 miles an hour. But the engineers at Breguet knew for a fact that this aircraft had a lot more to give. In fact, during an earlier test flight, the jet had already pushed past 663 miles an hour. However, the numbers had not been officially recorded. The team's persistence paid off. They went for another attempt on July 23rd, and this time the instruments showed a staggering 667 miles an hour. Riding high on this triumph, they quickly upgraded the aircraft to meet NATO's new, stricter requirements for second-generation tactical strike fighters. It looked like the jet had a bright future ahead of it. But NATO command suddenly scrapped the requirement for this class of aircraft entirely. Because of that decision, this unique prototype was unfortunately sent straight to the scrapyard. Besides the baseline tactical strike aircraft, the developers had been planning to roll out two other interesting variants. These were meant for very different roles, each with its own dedicated equipment. They likely never even received official designations. The first variant was a photo reconnaissance aircraft. Its nose section was specially redesigned to fit an entire camera suite. the radio gear had to be relocated to the right fuselage bay. This bay usually held the armament. Because of this, firepower was concentrated strictly on the left side. They planned to install either two 50-caliber machine guns or a single hard-hitting 30mm cannon. The reconnaissance payload was set to include 5 special Omera 31 cameras. 3 were mounted at angles to cover the front and sides. The other 2 pointed straight down. Importantly, in terms of flight performance, this recon plane would be right on par with the baseline light fighter. The second variant was a 2-seat trainer. The instructor and student sat in a tandem configuration. Most of the armament was simply stripped out. They wanted to equip this version with the Orpheus 4 engine. This was a slightly less powerful variant of the Orpheus 3 power plant, but in exchange, it was more reliable and offered a significantly longer service life. Now let's take a look under the skin and see exactly how the Breguet 1001 was put together. Just like its sibling, the Breguet 1100, it used some truly cutting-edge technology for the era. This technology featured bonded honeycomb sandwich panels. This made the aircraft's structure incredibly strong while keeping it exceptionally light. Each wing was built around a sturdy framework featuring 2 milled spars. The metal skin attached to them gradually tapered in thickness from the wing root all the way out to the tips. The entire internal space was filled with a honeycomb core. The wing's moving control surfaces and the main landing gear struts were attached directly to this core structure. The wings themselves were actually pretty thin. They sported a thickness-to-chord ratio of just 6%, with a sweep angle of 43 degrees. Interestingly enough, internal wing fuel tanks were never even part of the design. The engineers focused heavily on the wing's high-lift devices. They went with 2-piece leading edge slats. They also used large, double-slotted flaps that spanned almost the entire trailing edge. The whole setup was hydraulically driven. Because those flaps took up so much space, there wasn't a lot of room left for the ailerons. To compensate, they used power-boosted controls and linked them to a pair of spoilers on each wing. The fuselage was designed around the area rule. This made it look a bit out of proportion compared to the compact wings. It was built in 3 main sections. These were the nose, center, and tail. The nose cone was hinged so it could easily swing open. This gave maintainers quick and easy access to the avionics. The center fuselage was the true core of the aircraft. This is where you'd find the pressurized armored cockpit. Just behind it were the bays for 4 machine guns. There were also 4 fuel bladders that held a combined total of 484 gallons of jet fuel. This is also exactly where the main landing gear tucked away after takeoff. The engine and wings were securely bolted to main load-bearing frames in the center fuselage. During flight testing, the designers actually had to make a major change. The speed brake, which was originally positioned under the tail, was relocated closer to the center fuselage for better handling. The aircraft's skin was made from honeycomb sandwich panels. Meanwhile, the inside was heavily reinforced with traditional bulkheads and stringers. The entire tail section was designed to be quickly removed. This was done specifically so ground crews could get immediate, unobstructed access to the Orpheus engine during routine maintenance. The tail assembly was bolted right to the rear fuselage. Interestingly, the all-moving stabilator was mounted fairly low. The very tip of the tail was made from heavy-duty stainless steel to withstand the high exhaust temperatures. Much like the wings, the base of the vertical stabilizer and the rudder used an internal honeycomb structure. This kept things extremely lightweight but incredibly rigid. And to help the pilot manage the heavy control loads at speed, the rudder and stabilator were linked to hydraulic servos. Right at the base of the vertical stabilizer, they tucked away a housing for the drag chute. This helped the aircraft bleed off speed quickly after touchdown. The landing gear was custom designed by Messier. They had a tough job on their hands. The aircraft had to operate smoothly from unimproved dirt fields and rough, unprepared airstrips. To pull that off, the engineers went with a trailing link suspension and low-pressure tires. These were running at about 50 pounds per square inch, so the plane would not sink into the soft ground. The heart of the aircraft was a powerful Bristol Orpheus BOR3 jet engine. Air fed into it through 2 side-mounted intakes with a rather unique design. They were triangular and offset slightly from the main fuselage. They acted as splitter plates that did a great job of bleeding off the turbulent boundary layer air. Underneath each intake was a special fairing that served a few crucial functions. First, it improved airflow to the engine at transonic speeds. Second, it reduced the risk of foreign object damage, or FOD, during takeoff. These fairings did not disrupt the airflow at all during hard maneuvering. They also doubled as deflectors to keep gun gas out of the intakes when firing. Speaking of which, that is exactly where the machine guns were housed. 2 were placed inside each fairing. Interestingly, the early intake designs looked a lot like those on the Lockheed T-33 Shooting Star. But after extensive wind tunnel testing, the engineering team completely redesigned them. On the first prototype, the cockpit was laid out in a typical French configuration. However, the second test aircraft featured instruments and flight controls tailored to British and American military standards. This made it much more intuitive for foreign pilots. Both aircraft were equipped with reliable Martin-Baker Mark IV ejection seats. The avionics package was cutting edge for its time. It included a high-power radio, an IFF system, a radio compass, a highly accurate gyromagnetic compass, and a remote guidance system. The bubble canopy had a simple opening mechanism. It slid straight back on rails. Its aerodynamic profile was carefully refined in the wind tunnel to give the pilot excellent all-around visibility during combat missions. The older rear-hinged clamshell canopy concept, originally considered for the BR-1001 and BR-1100 programs, was dropped very early in development. To protect the pilot, the front windscreen was made of thick, armored glass. The cockpit tub itself was fitted with heavy armor plating. Now for the armament. The primary weapons loadout consisted of 4 .50-caliber Browning heavy machine guns. Mounted in pairs on either side of the fuselage, they carried a total of 1,200 rounds of ammunition. The engineers really kept operational readiness in mind, too. The guns were mounted in modular weapon trays. This meant ground crews could pull them out and swap them in a matter of minutes. If a mission called for it, those 4 machine guns could be quickly swapped out for 2 hard-hitting 30mm DEFA cannons. Alternatively, they could load 2 Matra rocket pods. Each pod carried 15 unguided 68mm Brandt SNEB rockets. Under the wings, there were 4 hardpoints for mounting external stores. Typically, crews would load them with 2 500-pound bombs or 2 napalm canisters of similar weight. Alternatively, the aircraft could head into combat with 2 Nord 5 and 03 guided missiles, also known as the AS-20. It could also carry 2 large 5-inch unguided rockets, or 2 jettisonable rocket pods, holding 12 or 19 rounds each. Notably, the center line of the fuselage was left completely clean. There were no weapon stations provided under the belly at all.